Now let's move to some real applications of what we've been talking about this week. No one measure will solve the environmental contradictions that now exist in our cities, suburbs, and their hinterlands. This will require a comprehensive suite of actions, well integrated and coordinated with land use and development reforms. No city has yet achieved such a holistic strategy, so no city can be said to be even moderately sustainable, partly because we only add about 1% to most urban regions each year. So existing conditions overwhelmingly determine performance. Performance rating systems are starting to clarify a sense of direction for future buildings. Some cities are adding a green agenda for public properties and services. But we're a long way away from comprehensive reform and retrofit. Yet real breakthroughs are starting to show up at the scale, particularly of city districts or neighborhoods. They're beginning to be places where some of the eco-design features are put together in the design of whole urban districts. And in this segment, I want to concentrate on three iconic examples from Europe, the Middle East, and North America. First, let's go to Sweden, where we find a neighborhood that has been long established and occupied and was an early exemplar of a more responsible way to build cities. Stockholm's Hammarby Sjöstad community occupies the site of an old port and an old industrial district, which is what the name actually means, port town. So here's the neighborhood plan. This was a contaminated brownfield site, which has been cleaned and redeveloped using the best currently available technology for sustainable energy, stormwater, and sewage treatment, as well as solid waste disposal, with the aim of cutting the negative environmental impacts in half compared with conventional development as practiced in Sweden in the 1990s. The plan was originally made as part of Stockholm's bid for the 2004 Summer Olympics, the one that ended up being held in Athens. And we're finding that such events, whether or not they actually happen in a community, can set off a creative process about new development. The completed district will include about 11,500 apartments, about 26,000 people, and over 10,000 people are also expected to work there. The district has its own heating and wastewater treatment plants. The heating plant is powered partly by combustible waste collected partly by biogas, some of which is produced by the district's sewage treatment plant, and also by heat converted from treated wastewater, which contains heated water from dish and clothes washers and from showers, sinks, and bathtubs. Some buildings are also fitted with solar panels. This diagram summarizes how it all comes together. Water consumption is reduced by using efficient toilets and air mixer water taps. Stormwater from the streets goes into a separate piping system where it's routed to holding tanks and a sedimentation pond to purify it before it's discharged. Rainwater from yards and roofs runs into a canal system, which filters it before it runs into the sea. Now back to the diagram, there's an automated waste disposal system fed by chutes in the apartment buildings. Combustible waste goes into the power plant. Organic waste is converted for use as fertilizer. There's also recycling rooms throughout the district. So what appears to be a pleasant but quite conventional neighborhood is actually an advanced prototype. Now let's shift over to the Middle East. Another hotbed of innovation is a new district called Masdar City in the United Arab Emirates. This new area is a fully planned development that is being undertaken by the Emirate government in order to test sustainable solutions and to model responsible development for other developers who are in the emirate. It's nestled within the larger urban region of Abu Dhabi City, adjacent to a large area that's designated and designed as the nation's new national capital district. Now, not much is actually built, so what I'm showing you today are really only drawings. So here's the community plan. Being in a desert, solar energy is an important part of the design of Masdar City, which is promoted as one day becoming a zero-carbon, zero-waste community. There are to be solar collectors along the walls that will screen the city from wind. solar collectors on the roofs of buildings, and an area devoted entirely to solar collectors outside the wall, in addition to a wind farm associated with the project. The desalination plant that supplies water for the area is also to be powered by solar energy. The design's intended to apply lessons from traditional architecture in the region. So buildings are kept close together across narrow streets to provide shade and shelter outdoors. Wind towers will capture and draw down cooling air currents, and windows will be protected by lattice shades. The district will cover about 607 hectares, or about 1,500 acres. It'll house about 45,000 people at build-out, and it'll have about 60,000 jobs as well. The first stage houses a university campus that will specialize in research for sustainable development, as well as the headquarters of the development company. A parallel benefit of this urban pattern is that the area is very hospitable for everyday living and for pedestrians in public space, which can be a challenge in the intense heat that you see in this region. Cars have to be garaged as soon as they reach the district boundaries. To some degree, this is a contradiction to the aspiration to be carbon neutral, because area workers will use their cars to access the area from all over Greater Abu Dhabi. There's also been criticism that the worker population is significantly out of proportion to the resident population, which makes commuting in for many workers an unavoidable necessity. To moderate this, there's to be a rapid transit connection to the key destinations in the greater Abu Dhabi region. But this is mostly a place to walk. The original intent was also to provide an electric-powered personal movement system, sometimes called a horizontal elevator. Well, this concept has now been abandoned, both because of complexity, but mostly because of expense. Now, as Abu Dhabi City was intended to be a center for research and attaining sustainability, it's understandable that its design and technology will evolve as the city is actually developed and built. So now let's shift to North America. Our last example is an interesting community called Southeast False Creek, but often just called The Village, back in Vancouver. We touched on this area in an earlier segment. This is a new neighborhood and a formerly industrial area just south of downtown Vancouver on the south shore of the city's major inner-city water body. The plan was complete in 2004, here it is, and the central portion was implemented as the Olympic Village for the 2010 Winter Games, and then converted to apartments after the Games were over. And this is another example of a big international event, the Olympic Games, setting off a process of creative design for an area. The final phases of the scheme are now in the process of being actively completed and occupied. The Olympic Village portion of the plan has received what is called a Neighborhood Development Platinum designation, the highest possible in a North American-invented, internationally recognized rating system called LEED, L-E-E-D, which stands for Leadership in Energy and Environmental Design. Now, if you don't know about LEED, look it up. It's very, very important. One reason for the rating is a neighborhood energy utility plant which uses waste thermal energy captured from a city sewage treatment station to provide space heating and hot water to new buildings in the whole village. This diagram shows how the system works. The plant is only for heating because residential air conditioning is really seldom needed in this part of the world. But the City of Vancouver says that this process eliminates more than 60% of the polluting emissions that would come from heating the buildings by conventional methods. The project also follows the well-known LEED approach to reducing overall energy and resources that are used by individual buildings, including collecting rainwater to flush toilets, energy-efficient exterior materials, and rain screens to protect exterior walls. And it meets other LEED requirements as well. Streets are narrow and lined with mid-rise buildings that provide a lot of light and sun at grade. Stormwater is channeled to a stream-like water feature within the adjacent local park that scrubs the runoff before it then goes into the sea. Waste is recycled, plots are assigned for residents' gardens, rooftops are greened, and there's a careful balance of housing with local shopping and civic standards for public amenities and services. Again, the emphasis is on sustainable utilities, but this hasn't taken the focus off the quality of life and day-to-day experience for people who live in Southeast Falls Creek. There's a strong social agenda built into the plan that includes secure, affordable housing for various levels of household income, a special target for households with children, and also housing set aside for those with special needs. The daily activities of local people are enhanced by a quality public realm, special facilities for recreation and adventure, local meeting places, and public art. This is a great illustration of the eco-design principle of making an environmentally sustainable place also attractive to consumers, so it performs well in the marketplace compared with the typical alternatives that are more environmentally impactful. Now, these three prototypes show that far more sustainable development is possible today for substantial urban districts using current technology. The innovations essentially replace more conventional components, so they do not significantly change affordability or financial feasibility, and both Vancouver and Stockholm districts have a subsidized housing component. They also show what begins to happen as all the dimensions of sustainability are brought together through a careful management of both public and private responsibilities. Next week, we'll discuss how eco-design can be brought up to the city, region, and even national level, and how it can start to address not only the 1% of new development that we constantly are adding to our cities, but also to a retrofit of the other 99% that's already built.